Good morning, my dear students, and welcome to this session. Where's the pen? The pen is missing. I believe everybody is here. So today we are going to start with a very important part of chemical kinetics. Chemical kinetics, what we have already done? We have already done the rate of reaction, what exactly it means. We have talked about the differential rate law. We have also talked about the rate law. We have talked about the effect of the concentration, how it affects the rate of the reaction. We have talked a little about what the order of the reaction is. We have talked about what the rate constant is. We have talked about the dimensions of the rate constant. And now today we are going to talk about the different kind of reactions. We are going to talk about different types of reactions. Hello beta Jitero, Tritik Prasad, Radhika Mittal, Priyanshu Ghosh, Tirth Raj, Ayush Mani. Okay, I believe Ayush Mani, I remember some of your name. Yes, Prerna Rajput. So we have 10 students watching. I'll just get my pen. This is missing here. I'll just check it out. Where is it? Just wait. So, jeete raho beta everybody. I hope you are understanding whatever we have been doing till now. So, let's get along a little further. So, we are going to talk about today, what exactly we are going to talk about? We are going to talk about the different kind of reactions. We are going to talk about what are the complex reaction, what are the simple reaction. We are going to talk about what is molecularity, what is the transition state, what is the rate determining step, and so on and so forth. Clear? Again, we are going to deal with the blank slides and I am going to teach you by writing it. So, I believe everybody has their NCERT books with them. You have your pen, you have your copy, and you are ready to make notes. Many of the students are asking me to send you the notes, but what other students are telling them is to make the notes in the class. And further, all the students who have made their notes are uploading the notes in the session. You can use the notes made by other students, but I sincerely, strongly advise against it. And the reason is your notes are the best because you have made it and you know what it is. Now, I was talking to a student yesterday only, and that student said something very simple, and that is, sir, when we read the notes, it is not the notes that we understand. No. We remember in what situation we wrote those notes. And those situations, when we realize that these were the situation in which we were writing the notes, we understand the concepts better. So, it is not the notes which are important, it is the situation in which we were writing the notes that became important, and those things we remember. So, that is why writing the notes becomes even more important. Is that clear? So, I will sincerely say that you have to write the notes, otherwise these are everything written in the book. We are reading the NCERT, we are underlining the NCERT, we are noting it down. So, it is much better if you write it. And we are doing very slow, we are not moving very fast. मजेदार बात पता है क्या है कि हम अपनी क्लास के अंदर बहुत आराम से पढ़ रहे हैं, बहुत ही आराम से पढ़ रहे हैं, और हमारा कोर्स भाग रहा है। मैं हमेशा ये बोलता हूं कि मैं बहुत आराम से पढ़ाता हूं, बहुत धीरे धीरे पढ़ाता हूं, और इसीलिए मेरा कोर्स सबसे पहले खत्म होता है। ठीक है. And I was reading a book, उसमें लिखा हुआ था slow is steady and steady is fast. That's what I do. So that's what we are going to do, and that's what we have is slow is steady and steady is fast. So remember this. This is the saying for today. This is the line that you need to do today. Slow is steady and steady is fast. So that's what we are doing, and this is what we have as Elixir Dropper batch for Neet UG 2024. This is the batch costing you 11,999 by using the code Elixir, ये WS Live, or you can use the code AV Live. Use the code AV Live, use the code WS Live, and you are going to get the course at 11,999. That is 12,000. You can say that, but 11,999 looks like very nice one. Fine. So join the batch very soon. This is going to be the batch timings. It's starting from 5th August onwards. It's 6:30 to 7:30 p.m. is Swati ma'am. 7:30 to 9 p.m. is me, Anoop Vashishtha. 9 to 10 p.m. is Dr. Sachin Kapur. This is what we have as the course. This is going to be course starting as far as chemistry is concerned. In this course, we are going to start with the organic chemistry. Organic chemistry start with, basically, we have Elixir Dropper batch for Neet UG 2024. Go ahead and get the subscription. WS code is applied and you get the course as 11,999. Any of the doubts, you can join with this particular phone number. Go ahead and join with this particular phone number. Ask them any confusions. That is me. You know who I am and what I am. चलो, let's begin over with the course. तो आप ज़्यादा टाइम इसमें नहीं लगाते हो, सीधा सीधा कोर्स पर आते हैं. ऋतिक प्रसाद, कछुए की चाल नहीं चलनी, हमें अपनी चाल चलनी है. ना हमें किसी और की चाल चलनी है, ना किसी और की बात सुननी है. हमें अपनी चाल चलनी है. मैं अपने तरीके से पढ़ा रहा हूं, मैं अपनी चाल पर पढ़ा रहा हूं. और आप खुद ही देख सकते हैं कि हमने एक एक दिन में, बल्कि दो दो दिन के अंदर हमने थर्मोडायनेमिक्स जैसा चैप्टर, इलेक्ट्रोकेमिस्ट्री जैसा चैप्टर खत्म कर दिया है. और कल हम सॉलिड स्टेट खत्म करने वाले हैं. तो हम शुरू बाद में करने की बात करते हैं, खत्म करने की बात पहले करते हैं. सो इस पूरी की पूरी फिजिकल केमिस्ट्री, चाहे वो 11th की फिजिकल केमिस्ट्री हो, चाहे हम 12th की फिजिकल केमिस्ट्री की बात करें, वी आर डूइंग इट वेरी रैपिडली. इज इट ओके? फाइन. एंड देन there would be a chapter called redox and there would be a chapter called equilibrium. और equilibrium से तो भैया मुझे बहुत पसंद है, डर नहीं लगता. आपको पता नहीं क्यों इक्विलिब्रियम से डर लगता है, बट होपफुली जब मैं आपको इक्विलिब्रियम करवाऊंगा तो आपको इक्विलिब्रियम से डर लगना बंद हो जाएगा. चलिए, लेट्स गेट along with the topic of chemical kinetics. Let's talk about the types of reaction. The types of reaction. Now, when we talk about the types of the reaction, we have the single-step reaction, we have the multi-step reaction. Single-step reactions are called the simple reaction or elementary reaction. So, we have the elementary or simple reaction. Elementary or simple reaction. The simple reaction or the elementary reaction are the reaction which take place in a single step. Now, what is the meaning of the single step? What exactly we define by the word single step of a reaction? Now, I'll just take an example. See, I have the pen in my hand. It's quite visible. Is it okay? Now, I take the other hand. Okay? Again. What is happening is, I'll do it a little slow. I don't know whether you have the capacity to make it slower or not, or you can just go back and you can just slow down the video and then you can see that it's going like this. Here I join it, but if I do it slow, I won't be able to do it nicely. It would be going like this. Here it touches, here it goes, here it forms the bond and it goes. It is one smooth motion and the pen moves from one hand to another. You cannot say that any instant the thing has stopped. It has just gone like this. One bond is being formed, other bond is being broken, and this is a single step reaction where the process once started does not stop anywhere in between. You cannot stop the process anywhere in between. If I ever try to stop the thing is like this is going to fall down. ये नीचे गिर जाएगा. तो दैट इज व्हाट वी हैव एज अ सिंगल स्टेप रिएक्शन, जहां पर पूरा का पूरा रिएक्शन के अंदर रिएक्शन कहीं पर भी बीच में रुकता नहीं है. यू कैन नॉट स्टॉप द रिएक्शन एनीवेयर इन बिटवीन. It is the starting, it is the end, and in between there is a position where the bonds are being formed and broken simultaneously. This is what we have as the transition state, where the reactant moves from reactant to the product. Okay, is that clear? Background बहुत डार्क नहीं है बेटा, ये यहाँ मैं बहुत डार्क लग रहा हूँ, यहाँ पे स्टूडियो के अंदर गड़बड़ हो रही है. फाइन. और आज तो मुझे लग रहा है कि फोकस काफी अच्छा है, तो बैकग्राउंड डार्क की तो बात नहीं है. बट स्टिल अगर बैकग्राउंड डार्क है, देन इन दैट केस यू विल बी एबल टू सी दिस व्हाइट very nicely. So that's what we have. Everybody who is in the class has already liked the session. Now, so elementary or simple reaction is a single step reaction. That is what we have as the types of the reaction. Clear? So, fine. Now, let's have a few example of the single step reaction. The very first example that we are taking is from the inorganic chemistry. Inorganic chemistry, the example that we take is, we have H2 gaseous reacting with I2 gaseous gives us 2HI gaseous. Now this is one reaction. Please remember, whether the reaction is a simple reaction, single step reaction, or a complex reaction, that is never predicted from the equation. You cannot see the equation and tell it that this is the kind of the reaction, because whether it's a single step or a multi-step reaction, that also depends on conditions. If you change the condition, that this reaction, which is supposed to be a single step reaction, can turn out to be a multi-step reaction. Okay, so under certain specific condition, it is a single step reaction. Now we are not going to talk about what those conditions are. Now how does it become a single step reaction? See, here we have the hydrogen molecule. This hydrogen molecule reacts with iodine molecule, or you can say it collides with the iodine molecule under a proper orientation. Fine. Now, when this collides, this forms a kind of a bond with iodine. The hydrogen-hydrogen bond weakens. The hydrogen-iodine bond is formed. Iodine-iodine bond weakens. This is a particular state which is the highest energy state in this reaction step. Highest energy state in the reaction step. And in this highest energy state, the bonds are being formed, the bonds are being broken, and this state cannot be isolated. You cannot take it out from the system. You cannot have this particular system. Okay, fine, this is the system. No, you cannot see it. You cannot extract it. You cannot store it. Now, this state is what we know as the transition state. This is the transition state. Am I clear with that? Okay, so this is what we have as the transition state, and after this, the hydrogen-iodine bond is formed, and hydrogen-iodine bond is formed. The hydrogen-hydrogen bond breaks, iodine-iodine bond breaks. This is a single step, simple reaction. Anybody has any confusion with that? Now, this is the transition state. So, we need to get the definition of what is a transition state. We know this is a transition state, but what is a transition state if somebody asks you? So, what we know is transition state. It is the highest energy state in any step of the reaction through which the reaction has to pass through but can not be stopped at. Okay? Transition state can not be isolated. Okay. Each step has its own transition state. Clear? So that means, so the number of transition states is equal to number of steps in the reaction. Anybody has any kind of any problems? Ritik, that's what I said. Transition state has the maximum energy. This is the highest energy state in the reaction. Fine? So tomorrow we are going to talk about the crystals, and let's see how many crystals get crystal clear to you. So tomorrow we are going to talk about the crystals, crystalline state. Any doubts? So each step has its own transition state, so the number of transition state is equal to the number of steps in the reaction. Everybody has written the statement? We can have a graph. Okay. Now here we are going to plot the energy. This is the energy, and this is what we have as the reaction coordinate. This is what we call as reaction coordinate. The very important thing is the reaction coordinate does not have any scale. It does not have any kind of markings. Reaction coordinate is not dependent on time. This does not give us any time. There is no marking. You can put the reaction coordinate small, you can put the reaction coordinate large. It just simply says that the reaction is proceeding. The reactant undergoes a change to form the product, and this reaction coordinate is just to do that, just to signify that, nothing more than that. वही दिखाने के लिए और कुछ नहीं है. So यहाँ पर reaction coordinate, you can make it small, you can make it large as you like. The length of the reaction coordinate does not make a difference. Now here the reaction could go like this. Here is the energy of the reactant. Here is the energy of the product. In this case, we have made the graph in such a manner that the energy of the product is less than the energy of the reactant. So this is an exothermic reaction. We could make the energy of the product greater than the energy of the reactant. It is going to become an endothermic reaction. As far as kinetics is concerned, that does not make a difference. What makes the difference in the kinetics is that this is the highest energy state in this particular graph, and this is the transition state. Okay, the graph has to pass through it, but it cannot be stopped here. This cannot be isolated. This is the typical characteristic of the transition state. Now, having talked about the word called the transition state, now we have something like a condition called a molecularity. Molecularity. Now, before we talk about molecularity, let me make it very clear what do we mean by the word molecule. Okay, because people get confused. So, why are you talking about molecularity here? The ions are involved. Why are you talking about molecularity when the atoms are involved? Why are you talking about molecularity here? The molecules are involved. So, what is the meaning of the word molecule? So, molecule is a species capable of independent existence under given set of conditions. Now we specify a given set of conditions. These are the conditions that we have, and any species which has a capacity to have its individual identity, it is capable of existing individually, is termed as a molecule. Fine. So there is what we term as a molecule. Everybody who's watching has liked the session. I've got 17 likes. Could we have a little bit more likes if anybody has not liked here as yet? So what would be the molecularity? Molecularity by definition becomes the number of independent species. Now these molecules could be, that is, atoms, molecules, or ions. Now, in a given set of conditions, the atoms could be existing, molecules could be existing, ions could be existing. So that becomes the molecularity of that particular condition. So molecularity by definition is the number of independent species. Now, independent species is molecules. I have defined what molecule is. The number of independent species taking part in a single step of a reaction is termed molecularity of that step. Okay, the number of independent species molecules taking part in a single step of a reaction is termed molecularity of that step. Fine. And obviously, if we have the single step of the reaction, only single step reaction, it becomes molecularity of the reaction. For single step reaction, it becomes molecularity of the reaction which is same as order of this reaction. For a single step reaction, the molecularity and order become same. Now for a single step reaction, as it is denoted, the molecularity becomes the stoichiometric coefficient. For a single step reaction, the stoichiometric coefficient define the molecularity and they define the order as well. But please remember, for a single step reaction. So that is what we have as for a single step reaction. Stoichiometric coefficients give the molecularity as well as order of the reaction. See, I have a peculiar nature that the students who are in my class, I simply keep on scolding them. मैं डांटता रहता हूँ हर समय स्टूडेंट्स को कि तुमने ये नहीं किया, तुमने ये नहीं किया, तुम ऐसे नहीं करते, तुम वैसे नहीं करते. बच्चे बहुत इरिटेट हो जाते हैं मुझसे. But you need to remember, but फिर आ गया ना but. You need to remember that I am telling you those things or dependent on which you get confused, or the things from which the reason assertion questions are created, the restatements from which the confusing questions are created. Here I said for a single step reaction. Now what the students would do is they will forget this part. And they will simply say, they will look at the reaction and say this is the molecularity, this is the order. Who told you that this is a single step reaction? First of all, you need to ask whether this is a single step reaction or not. You simply give your verdict that this is the answer. And that's what you have very well understood, that whenever we are having the questions at 8 p.m. class, today also we have the 8 p.m. special class in which we are going to do the chemical kinetics question, you fail to read the question, you fail to see the trick in the question, the twist in the question. Okay, you have to read it thoroughly. The NEET examination gives you 1 minute to answer a question, but actually it is less time for a biology question, more time for a physics question, but 1 minute for a chemistry question. That time is there for you to read the question carefully. The questions are not going to involve the calculation, because if the calculations are involved, you won't be able to do the question within the given time. You are given the time to read the question carefully and answer the most appropriate answer from the given options. Clear? So, for a single step reaction, stoichiometric coefficient give the molecularity as well as the order of the reaction. For this particular reaction, H2 plus I2 giving you 2HI, the molecularity is 2 and the order of the reaction is also 2. So, this is a second order bimolecular single step reaction. Are we getting the information here? Anyone has any kind of confusion? Whoever has not liked, just like it. Ananya Saka, there is no trick in physical chemistry. There is no trick to find the molecularity. Either you know it or you don't. Okay? You have to determine these things experimentally. Whether the reaction is a single step reaction or multi-step reaction, that is determined experimentally under the given set of conditions. So don't see the tricks here, because the most important thing again, the question that will be asked will be from NCERT. So whatever example are given in the NCERT, that only will be asked. So why do we need that trick? We know it. We require the tricks for unknowns. But here there is nothing unknown. Everything is known. Is it clear? So this is what we have, a single order, single step reaction, second order, single step reaction, bimolecular reaction. Now let's have an organic reaction. We have CH3Br reacting with KCN in presence of ethanol to give us CH3CN plus KBr. Now this is an actual reaction that takes place. This is what we have as a substitution reaction. This is a nucleophilic substitution reaction. I believe all the students that are attending the class, they are the 12th pass students, so they have an idea about the nucleophilic reaction, what they are. Now let us look at the mechanism of this particular reaction. What is the mechanism? How does this reaction take place? Okay. Fine. So, now let us see how this reaction actually takes place. Here we have the cyanide ion, and here we have the methyl bromide. Here we have the cyanide ion, here we have the methyl bromide. Now, this cyanide ion attacks on the carbon, and quite obviously, why cyanide ion attacks on carbon? Why does it not attack on hydrogen? Why does it not attack on bromine? The very simple reason is the positive and negative attract each other. Now, the cyanide ion carbon has a negative charge, and this particular carbon, since it is attached to bromine, it is going to have a positive charge. So, quite obviously, negative is going to attack on positive. Any confusions, anybody? Okay. So, this is going to reach towards carbon, and now there somebody says, sir, why is it attacking from this side? Why is it not attacking from this side, this side, this side, this side? Obviously, why is it attacking from this particular side, or you can say the side opposite to bromine? Now, I said that positive and negative attract each other. Did I not say that negative and negative repel each other? Now, this bromine is going to have a negative charge, cyanide has a negative charge. So, quite obviously, since carbon is attracting it, the bromine is going to repel it. So, is it not very, very obvious that cyanide will attack from the position which is farthest from bromine? Where is the confusion? I fail to see that. Where is the exception? I fail to see that. So, cyanide is going to attack from the position which is farthest from bromine. When it attaches here, now we get a situation in which cyanide has not actually formed the bond and bromine has not broken the bond. Now, this is going to be N, here it is going to be triple bond C, here it is going to be a bond which is being formed, and a bond which is being broken. Now, this carbon would be having a delta negative charge, bromine is going to have a delta negative charge, carbon obviously has a positive charge here. Now, the cyanide is approaching in and bromine is moving out, and finally, this is what we can say is the transition state. This is the transition state. This is the highest energy state in which carbon has 5 species attached to it. This is a penta-coordinated carbon. Carbon does not have the valency of 5, carbon does not exceed the valency. So, here it is going to be a penta-coordinated, that is carbon has 5 species surrounding it. It is a very difficult arrangement. This is a highest energy statement. This is going to be formed, and then finally, we are going to get N, C, and here it will be carbon, hydrogen, 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 and bromine has been ejected out. This again is a single step reaction. This again is a bimolecular reaction because there are 2 species involved in this particular reaction, this step. It is a bimolecular reaction. This is a second order reaction. Now, cyanide is a nucleophile. Nucleophile means which attracts the nucleus. Bromide is a nucleophile. Again, it is attached to the nucleus. So, one nucleophile has replaced another nucleophile. So, the name of this reaction is, it is termed substitution. Substitution. One species is substituting another species. Nucleophilic. Substitution nucleophilic, because one nucleophile is replacing another nucleophile. Bimolecular. Why it is bimolecular? Because 2 molecules are involved in this particular reaction. So, this is substitution nucleophilic bimolecular, which is in short written as SN2. Substitution nucleophilic bimolecular. So, SN2 is not just the name of the reaction, it is the mechanism of the reaction. Now, this reaction is going to be a second order reaction. If here we talk about the rate of this reaction, the rate of this reaction is going to be K into the concentration of CH3Br into the concentration of Cn minus. Of course, Cn minus concentration is the same as KCn minus, KCn concentration, but fine, this is how we write the reaction. So, this is a second order reaction. The order with respect to CH3Br is 1, order with respect to cyanide is 1. Am I clear? Anything you want to ask about this particular reaction? So, we are talking about the organic chemistry also in chemical kinetics. Quite obviously, when we talk about organic chemistry, the reasons of any reaction is going to be given by thermodynamics, the mechanism is given by kinetics. Any doubts? Clear? Now, when we talk about the molecularity, what would be the molecularity of any reaction? Now, there could be a unimolecular reaction, single molecule reaction. A single molecule reaction would mean that a molecule is undergoing the change within itself. You are providing the energy, the molecule simply breaks apart. That could be a unimolecular reaction. The step could be just one. Then the biomolecular reaction, two species combine with each other to give the product. Now let's think about trimolecular reaction. What would trimolecular reaction mean? A trimolecular reaction would mean that we have three species, 1, 2, 3. The three species collide with each other at a single instant. Single instant. It is something like that three people, they try to clap and they hear just a single sound. Okay. Quite a difficult prospect. Quite a difficult prospect. And that too, when you have your mind to coordinate it, you have a particular scheme to coordinate it. If you talk about simply random thing, is it possible? Is it possible that the three particles strike at the same point at the same instant? Okay, let us see that it is possible. Obviously, it is going to be very rare. So that is why the trimolecular reactions are extremely rare, and beyond 3, we don't have a molecularity. We don't have a tetramolecular reaction. We don't. So the tetramolecular reaction is not possible. Harsh, is this clear? We have already made it clear. So that is the reason why high molecularity or molecularity above 3 is not observed. Well, in chemistry we do not talk about it does not exist. In chemistry we have a tendency to say that I have not observed it. I don't know about it. So chemistry, you have to accept you don't know it. Fine. So that is what we have a term called molecularity. This is the molecularity of the reaction. Once we have talked about the molecularity of the reaction, that molecularity above 3 is not observed, now let us talk about one very important thing. That is what we call as the rate determining step. Rate determining step of the reaction. The rate determining step of the reaction. Many a time students feel that rate determining step is the slowest step, but I disagree with that. Again, there will be an exception. So I just don't want those exceptions to take place. Rate determining step is not the slowest step per se. It is actually the most difficult step. Difficult doesn't mean slow. Okay. So it is the most difficult step in reaction. But then why do all the books call it a slow reaction? Why do they call it slow step? Let us understand what do we mean by the speed. The speed is not how much time a step takes. Speed is how many steps take place per unit time. Okay, how many actually take place per unit time? It's a little bit of confusing. Yes, I understand. कि सर अगर एक चीज में 5 सेकंड लग रहे हैं तो 1 मिनट के अंदर 12 होंगे ना, इसमें सोचने वाली बात क्या है ना? बट ऐसा होता नहीं है. Let us see, there is a 100-meter stretch. This is a 100-meter stretch. Okay. There is a race going on, a race. And here is the start line. Clear? Now here we are not counting how much time each person takes. We are not counting that. We are counting how many people reach this line in 1 minute. I don't bother because each person is independent. It is not 5 second one to 10 second, 5 second another one. No. It is all going on together at the same time. Each is independent of other. So whether each person takes 15 seconds or each person takes 25 seconds or each person takes 59 seconds in 1 minute doesn't make a difference how many people reach. All people could take 59 seconds, fine enough, they reach in 1 minute, they are counted. All people take 5 seconds, still they reach in 5 seconds, and 55 seconds nobody reaches, again the same thing. So it is not about how much time each person takes, it is about how many people reach this line independently from each other. Clear? And now what I do is, I erect a wall in between. Now this wall has a height of 7 feet. The wall has a height of 7 feet. 7 feet would be, okay, I am nearly 6 feet. I am actually 5 feet 11 inches, 5 feet 11.2 inches. So if I raise my hand like this is going to become something like 7 feet. 2 foot का मेरा हाथ भी है, ठीक है? यहाँ तक अगर मैं यहाँ से यहाँ तक के लिए लूँ तो it is something around 24 inches. तो इतनी हाइट पे अगर मैं कूदना चाहूँ तो it is not going to be easy for me to jump this particular thing. And of course, my age is more than twice your age. Okay. So if I am going to try to jump through this wall, if I am able to jump this wall, I don't think so it is going to take me more than 10 seconds. I'll run, jump, hold it, rise myself up, move on the top of the wall and jump down. It's not going to take more than 10 seconds. But the question is whether I am able to jump it or not. So how many people reach here is not the matter of how much time they take to jump through the wall. It is how many people can jump over the wall. And this wall becomes the most difficult step in this process. All those people who are capable of jumping over the wall will always be able to reach here. So rather than counting at this point, I can simply count at this point that how many people are crossing it. That's the rate of the reaction. So this becomes the most difficult step in the reaction or the rate determining step. ठीक है, ऋतिक प्रसाद कह रहे हैं कूद जाएंगे. तो यहां पर हमारे पास जितने भी स्टूडेंट्स हैं उनमें से कुछ स्टूडेंट बता दें भैया कितने लोग सोचते हैं कि वो ये 7 फुट की दीवार कूद सकते हैं और कितनी नहीं कूद सकते. वी हैव 11 स्टूडेंट्स वाचिंग and we will right now understand what will be the rate of the reaction. Fine. So this is what we call as the rate determining step, the most difficult step in the reaction. समझ आई बात? Anyone has to ask anything? What does the wall represent in the reaction? The wall could be representing the energy. Wall could be representing the orientation. Okay, clear? Wall could be representing, most often wall represents the energy the reaction requires. It is energy or orientation. That is the rate determining part. Clear? टाइम मैटर नहीं करेगा. इसमें कितनी देर से कूद रहे हो वो टाइम मैटर नहीं करेगा, बिकॉज यहां पे हम पर यूनिट टाइम लेके चल रहे हैं. क्लियर? इफ एवरीबडी टेक्स एन आवर in this particular part, I don't know, this particular part will become again the rate determining step. How many people cross per unit time? Fine. So this is what we call as the rate determining step. the most difficult step in the reaction. If it is made easy, the rate of reaction has to increase. Let's say you make the wall 6 feet. Now you make the wall 6 feet and the reaction is going to change drastically. Drastically. As you very well understand that if you talk about the high jump or long jump, the winner and the loser, they don't have much difference. There is no difference of feet. There is a difference of centimeters and nowadays maybe millimeters. Is this clear? So that is what we have as the most difficult step in the reaction. That is how the reaction proceeds. Everybody who is in the class has liked the session. Okay. So what we know? Rate determining step we have already understood. Now let's talk about a complex reaction. Complex or multi-step reaction. Okay. A reaction consisting of more than one elementary reactions. A reaction consisting of more than one elementary reactions. Fine. So now let's understand this multi-step reaction. देखते हैं multi-step reaction क्या होता है. Let's talk about this example. We have a compound CH3 thrice CBr. Okay. This is called tertiary butyl bromide. Tertiary butyl bromide. Tertiary butyl bromide. Now this again reacts with potassium cyanide, KCl. Okay. Again, it is in presence of ethanol as a solvent. And here again we get CH3 thrice C Cn plus KBr. Now this is the reaction that we get. Now how does this reaction takes place? The mechanism of this reaction, and again what I am talking about is what we have observed, not predicted. We are not predicting the mechanism, we are just understanding, we are observing the reaction. Now, what happens is we have this CH3 C CH3 CH3 Br. Here this carbon is quite clustered. So it is difficult for cyanide to approach this particular carbon. It is difficult for the cyanide to approach this particular carbon. So what is preferred in this case is that here the solvent interacts with bromide and separates it out. So solvent extracts Br minus, solvent surrounds this particular species. So Br minus moves out from this particular state. So there would be some position where bromine is just moving out, and that could be something like a transition state. So we have CH3, we have C, we have CH3, we have CH3, and this bond is being broken. And here we have the solvent, and here we have the solvent which is trying to move it apart, and this is what we have as the transition state, and I would write it as 1, or I would write it as TS1. So this is the transition state 1. Now once bromine is taken out, we get a species like this. This species is called a carbocation. This species is called a carbocation. Now this particular species is highly reactive, It is a highly reactive species, but this species has some stability under the given condition. So, if a proper condition is provided, this can be isolated and studied. Not easy, difficult, but can be. Now, this species which is formed in the course of the reaction, which can be isolated and studied under given condition, is not called a transition state, it is called a reaction intermediate. So, carbocation is a reaction intermediate which is formed in the reaction. तीर्थराज BUTYL, AL नहीं है. So, this is an intermediate which is formed in this reaction. This is what we have as a carbocation. So, let's write the definition of an intermediate. A reactive species formed in the reaction and consumed, but can be isolated under specific conditions is termed intermediate. ठीक है? And just remember, it is a low energy state between two consecutive transition states. Okay? Intermediate marks the end of one step and beginning of the next step. Okay? The number of intermediates is one less than number of steps, and you know that the number of steps is equal to the number of transition states. So, it is or transition states. So, that is what we term as the intermediates. Harsh, it is tertiary carbocation. Carbonation is a process. यार ऐसी स्पेलिंग मिस्टेक मत किया करो, फिर खुद कंफ्यूज हो जाओगे क्योंकि तुमने पता नहीं क्या लिख दिया होगा और कहोगे सर आपने लिखवाया था. Have you noted it down? What is an intermediate? Any confusions? Any problems? What is an intermediate here? Okay. So having talked about what is an intermediate, this is the first step of the reaction. So this transition state 1, this is what we talk about the first step of the reaction, and we end up with an intermediate, the carbocation as an intermediate. Anything you want to ask here? Okay. Now what happens next? This is the carbocation. Now this is surrounded by the solvent. The ions do not exist in the gaseous phase. The ions either exist in the solid phase, stabilized by the lattice energy, or they exist in a solution stabilized by the solvation energy. Ions do not exist independently in the gaseous phase. Okay. Now this is what we have as the solvated ion. Now this solvated ion interacts with Cn minus. Now this again is solvated. So we get again a transition state. Now this transition state is where the solvation sphere breaks apart. We have C, CH3, CH3, CH3 positive interacting with Cn minus, the entire solvated, and finally we get CH3C, CH3, CH3, Cn. Okay, fine. That is the product which is formed. So this is the transition state, or I can say TS2, the transition state 2. Clear? And the product is formed. Now what is observed is, the second step requires much lower energy. This is quite easy to take place, whereas first step required a lot of energy. Fine. So this is actually an easy step. This one is an easy step. If we talk about the graph of this particular reaction, the graph of this reaction goes this is TS1, this is TS2, and this is the intermediate. Fine. So this step requires the highest energy. So the first step is rate determining step. First step is the rate determining step, which requires the maximum energy. This is the most difficult step. If the first step takes place, the second step is bound to take place. That is not going to be a problem unless and until we stabilize the intermediate and don't allow it to react. That is a different case altogether. Fine. So this is the first step, is RDS, rate determining step. Now when we talk about this first step has one species only. Solvent is not considered. Solvent is in a huge excess. The change in its concentration won't make a difference. So solvent is not considered. That simply means that the first step has only one species involved in it, and that's the alkyl halide or haloalkane. Okay, has only one species. So first step becomes a unimolecular step, while the second step is a bimolecular step. First step is a unimolecular step, second step is a bimolecular step. Now, for a complex reaction, as such, molecularity has no meaning. There is no molecularity of the complex reaction. But for a complex reaction having a well defined RDS, every reaction is not going to have a well defined rate determining step. There could be many obstacles. That one obstacle could become rate determining step for one step, and the other obstacle could become rate determining step for the other, because they are very near to each other. But if there are many reactions in which we have many steps which could become the rate determining step, then in that case we can't say anything about the molecularity. That is just experimental then. Now, for a complex reaction having a well defined rate determining step, molecularity of RDS is considered. Molecularity of the reaction. Okay. So, molecularity of the rate determining step is considered the molecularity of the reaction. ऋतिक, स्लोएस्ट स्टेप भी नहीं, स्लोएस्ट स्टेप ही. और स्लोएस्ट स्टेप कौन सा होता है वो मैंने आपको बता दिया. इट इज द मोस्ट डिफिकल्ट स्टेप ऑफ द रिएक्शन. क्यों अपने आप को कंफ्यूज करने की कोशिश कर रहे हो? Why do you want to confuse yourself? If you have understood something, let it be. Does anybody have to ask anything here? Anyone has to ask anything here? Okay. So, if we talk about this particular reaction, we have the reaction as CH3 whole thrice CBr plus KCN giving us CH3 whole thrice CCN plus KBr in presence of ethanol. Ethanol, this is a multi-step, in fact 2 steps. This reaction has 2 transition state and it has 1 intermediate. Okay, it's a multi-step reaction. Now, the RDS is bimolecular. So, this reaction is substitution. Oh, RDS is unimolecular, it's not bimolecular. Okay, this reaction is substitution nucleophilic unimolecular, or this is written as SN1. Now, if we talk about the rate of this reaction, that will be the rate constant K into the concentration of CH3 whole thrice CBr. This rate of the reaction is not going to depend on the concentration of KCN. So, this is a first order reaction. This is a first order reaction. You might be saying that, sir, why are you doing it in so detail in chemical kinetics? I am doing it in so detail in chemical kinetics because it will be used in organic chemistry as well. And I am a person who's going to teach you organic chemistry, inorganic chemistry, physical chemistry. So if I get a chance to explain organic chemistry in physical chemistry, I will do that. Is that clear? Anybody who has not liked the session, go ahead and like it. I don't know why I need to tell you that. It should be very clear from your side only that you are going to like the session whenever, the moment you enter the class. Is this clear? किसी को कुछ पूछना है पूछ ला लो, बिकॉज दीज आर द पार्ट्स विच यू जस्ट सिंपली स्किप ओवर. अरे यार कौन पूछता है इसमें से कुछ, फिर उसके बाद में जाके कंफ्यूज हो जाते हो एंड देन यू से सर कुछ समझ नहीं आ रहा. अब ये रियलाइज नहीं होता कि समझ में कहां नहीं आ रहा था. नहीं ऋतिक, डबल लाइक नहीं करना, सिंगल लाइक ही करना है. अटेंडेंस एक बार होती है, बार बार नहीं होती. ठीक है, हर क्लास के स्टार्टिंग में अटेंडेंस होती है. और नेक्स्ट क्लास वी आर गोइंग टू हैव एट 4 o'clock, सो वहां पे भी अटेंडेंस लगा देना. और इनफैक्ट आई बिलीव 4 o'clock के सेशन के अंदर जाके अभी से तुम अपनी अटेंडेंस लगा सकते हो. तो पहले ही अटेंडेंस लगा दो, बार बार करने की जरूरत ही नहीं पड़ेगी. सेशन तो लग चुका है ना 4 o'clock का. So this is what we have as the first order reaction. Fine. So we have just understood what is the transition state, we have understood what is the reaction rate determining step, we have understood what is the intermediate, what is the steps of the reaction, what is the molecularity. Anyone has any doubts in any of these terms? Any doubts in any of these terms? Fine. Now we get along with another reaction, a very, very, very important reaction. And now we talk about something called hydrolysis of esters. Hydrolysis of esters. Esters की अगर hydrolysis की बात करते हैं, when we talk about when the esters are getting hydrolyzed, there are two mechanisms of hydrolysis of esters. One is termed as the basic hydrolysis of ester, another one is called the acidic hydrolysis of ester. So we are first of all going to talk about the basic hydrolysis of ester, and then we are going to talk about the acidic hydrolysis of esters. Clear? So first we talk about the basic hydrolysis of esters. Now basic hydrolysis of esters has a specific name. This is also known as saponification reaction. This is called saponification reaction. The basic hydrolysis of esters, the saponification reaction. Now what the basic hydrolysis of ester and saponification reaction is? We have an ester CH3COOCH3. Okay. We react it with OH minus. Clear? When we react it with OH minus, we get the product, and of course H2O is the medium. We get the product as CH3COO minus plus CH3OH. So these are the products that we are going to get. Now let's see the mechanism of this reaction. CH3 C double bond O O CH3. This reacts with OH minus. Now quite obviously OH minus is negative, so it is going to attack on the position which is the most positive position, and the most positive position in this particular system is obviously again carbon. So this is going to attack over here, this carbon. Now carbon has a valency of 4. Now again you would say, sir, कहाँ से attack करेगा? तो यार सोचो ना यार, carbon has the positive charge, oxygens have the negative charge, so it is going to attack from the side which is the farthest from the oxygen. Fine. Now carbon has a valency of 4 and here there are 4 bonds already formed. Carbon cannot accommodate it and now it has a chance to break this bond. So its bond is broken. Okay, obviously there are transition states. No doubt to that, every step has a transition state. We are not bothered to, like, this is approaching it, this bond is breaking, so that's what we have as a transition state. But then we have the intermediate which is going to be formed, and that intermediate would be CH3. Here we have C, this is O with a negative charge, this is O, this is CH3, and this is OH. So this is the step 1. Fine. In the next step, we have the water molecule. This oxygen's electron is going to attack on this hydrogen. This is going to be cleaved and OH minus is going to be released out. So OH minus is consumed in the first step, it is formed in the second step. And we get CH3, C, OH, O, CH3, OH. Now this reaction has excess of water. Water is the solvent here. So whatever is excess, that is consumed. Whatever is less is formed. That is what we say as equilibrium. Equilibrium is that about that only. So in this case, water will be consumed and this CH3OH will be formed. And we get CH3CO OH plus CH3OH. Now the CH3COOH is again going to react with OH minus. Water is going to be released out and I am going to get CH3COO minus. So see, OH minus is consumed in the first step, formed in the second step, consumed in the fourth step. Third step is this, fourth step is this. So OH minus actually is the reactant in his case. So as the reaction proceeds, OH minus will be consumed. OH minus is neither the solvent, the OH minus is not the catalyst, OH minus is a reactant. Is there any confusion here? Now when we talk about the steps, the first step itself is the rate determining step. The first step is the rate determining step. Now the first step is bimolecular. So here this reaction is bimolecular second order reaction. This reaction is bimolecular, this reaction is second order reaction. Now, if I talk about the rate of this reaction, the rate of this reaction is going to be K, that is the rate constant, multiplied by CH3COOCH3 into the concentration of OH minus. So that is the rate equation for the hydrolysis of ester in the basic medium. Yes, Radhika, I told you, the first step is RDS. I have written it. Okay. Anyone has confusion here? Anybody who has not liked the session, go ahead and like it. Anyone? Anything to ask here? I hope my writing is not too bad. I perfectly understand it's not good. Fine. So that's what we have talked about, the basic hydrolysis of esters. Now let's get along with the acidic hydrolysis of esters. So to get along with the acidic hydrolysis of ester, we have the ester again, CH3, C double bond O, OCH3. Okay. Now, it interacts with H plus. Acidic means H plus. Okay. So, acidic means H plus. Talking about this H plus, this oxygen attacks over. See, these arrows, they don't talk about the movement of atoms. The arrows talk about the movement of electron pairs. So, electrons are available with oxygen, so electron pair would move towards hydrogen. Now, here the coordinate bond is being formed, so there is nothing, no breaking of the bond as such. Clear? So, this gives us an intermediate, and that intermediate is CH3, C double bond OH, OCH3, and here this oxygen has a positive charge. Now, please remember, the positive charge on oxygen is not the actual charge on oxygen. This is a formal charge, a theoretical charge. It is not an actual charge on oxygen. Fine? This is the formal charge the oxygen has. Actual charge is on carbon only. Now we get water. H2O की जगह मैंने OH2 लिख दिया, don't get confused with it. Clear? And I have written OH2 just because the oxygen has an electron pair and I have to attack it from the side of oxygen. So here it attacks onto this position. The bond cleaves. This is the second step, and what we end up with is CH3, C, OH, OCH3, OH, H positive. Now here H plus is released out. H plus is released out. Clear? So, first step H plus is consumed, third step H plus is released out, and we get CH3, C, OH, OCH3, OH. Fine? And then CH3OH is removed from here, and we get CH3COOH. The overall reaction becomes CH3COOCH3 plus H2O in presence of H plus gives us CH3COOH plus CH3OH. Fine. Now, for this reaction, this is rate determining step. Observation, this is the rate determining step. Any problems? Anybody has to ask anything here? Koi confusion? Now, when we talk about this particular reactions and we talk about the rate determining step, this rate determining step is a bimolecular step. Now, this step is, when we say rate, according to the rate determining step, will be equal to K1, let's say put 1, into the concentration of CH3COOCH3H plus. Now, this is the species, into the concentration of H2O. But the problem is, this is an intermediate. This is an intermediate, and we do not give the rate of the reaction in terms of intermediate. We do not give the rate of reaction in terms of intermediate. Clear? And if we do not give the rate of the reaction in terms of intermediate, there becomes a problem, because we need to get the intermediate in terms of the reactant and product. Noted down till this point? Anyone has any confusions, anything to ask here? There are two students who have run away. ज़्यादा हो गया लगता है. So what we can know is that CH3COO plus H plus gives us CH3COOCH3H plus. ठीक है ना? अगर हम इस रिएक्शन की बात करें तो this reaction could be an equilibrium, because the next step to it is a rate determining step. It's a slow step. So kind of an equilibrium is established between these two. This is a fast step. ये वाला fast step है. तो जितना ये बाहर निकलेगा उससे ज्यादा अंदर आ जाएगा, वापस आ जाएगा, उतना ही वापस आ जाएगा. So there will be an equilibrium established, and this equilibrium could be the equilibrium constant K. Okay. Now what is this K? K would be equal to the concentration of the product CH3COOCH3H plus divided by CH3COOCH3 into the concentration of H plus. So we may consider that the concentration of CH3COOCH3H plus is equal to the equilibrium constant into CH3COOCH3 into the concentration of H plus. Just remember, the rate equation is never written in terms of intermediates. You have to convert the intermediate in terms of the reactants and products. Welcome Akshay Thakur. So you are again here, so be here, attend all the classes now. And you have to be there, Akshay, in the evening class, in the questions as well. At this moment we have many options, we can use that. Okay, be there in the special class at 8 p.m. So that's what we have as the equation. So we can substitute it here, and we get rate is equal to K1 K into concentration of CH3COOCH3 into the concentration of H plus into the concentration of H2O. Is this clear? Now the twist comes in this particular system. H2O is solvent. H2O is a solvent, so concentration of H2O is constant. Does not make a difference. Even if H2O is consumed a bit, it is not going to change the rate of the reaction. हाँ तीर्थराज, आज स्पेशल क्लास के अंदर काइनेटिक्स होगा. You can check it out. स्पेशल क्लास लग चुकी है. Just go and register yourself to the special class. Okay, go ahead and register yourself to the special class. This needs to be done proactively. You don't need to wait for it. You have to do it. Okay, so H2O is a solvent. It is concentration is constant. H plus. अब मजेदार बात देखो, H plus is consumed in the first step and is formed in the third step, and then it is not consumed. H plus is catalyst. H plus is catalyst. So again, concentration of H plus is constant. Okay, so we have rate is equal to K1 into K into concentration of H plus into concentration of H2O into concentration of CH3 COO CH3. Now this part is a constant. Anybody has to ask anything here? This part is the constant. किसी को कुछ पूछना है? Any doubts? So that means rate is equal to K into CH3 COO CH3. Now if you talk about this reaction, it's a multi-step reaction, it's a multi-molecular reaction, but one of the reactant is a catalyst, another reactant is a solvent, so the reaction becomes a first order reaction. So this reaction is, although a multi-molecular reaction, but the reaction behaves as a unimolecular reaction as its experimentally determined order is 1. So if a species behaves as what it is not, it behaves something as different species, it's termed as pseudo. So this is not actually a unimolecular reaction, but it behaves as a unimolecular reaction, so it is termed as a pseudo unimolecular reaction, and books say pseudo first order reaction. Although I don't like the word pseudo first order, this is the first order reaction. Why should it be called pseudo? But it's a pseudo unimolecular reaction because it's not a unimolecular reaction. So this is a pseudo unimolecular reaction. Acidic hydrolysis of ester in water as a solvent is a pseudo unimolecular reaction. Okay, it is a observed first order reaction. Anyone has any doubts with that? With the pseudo unimolecular reaction? So we are going to talk about the integrated rate law and the effect of the temperature and the catalyst and the nature at 4 p.m. today. So remember that 4 p.m. class, and you need to join that 4 p.m. class. Go ahead and like that session and register for the 8 p.m. special class. Okay? So that is what we have as the pseudo unimolecular reaction, and this is the session today, this morning session. It's 90-minute session today. So unlock our biggest offer, that 25% off on all Plus and Store subscription. You can go on, limited period offer, use the code AVLive. You can use the code AVLive for getting any of the course of Unacademy. You can go in for the store, you can go in for the offline course, you can go in for the online course, you can go in for my course, you can go in for anybody's course for this particular code AVLive. Go ahead and use the code AVLive, whatever you do on Unacademy. ठीक है बेटा Ritik, we can have the class in the morning also. Ananya, it's not break. The class is over for the morning session. We are going to have the break in the evening class because that's going to, I hope, a longer class. Poonam Singh, मजा आ गया तो रोज क्यों नहीं आते बेटा? You have to be regular, and I hope you have already registered yourself to on that website where the questions are there, and you have joined the Telegram channel, you have joined the WhatsApp channel. So go ahead and join, interact with each other, get your questions, and I hope before we start over with the next class, that is going to be at 2 o'clock botany class, you will have the notes already uploaded on that WhatsApp group. Okay, upload your notes on the WhatsApp group. Clear? Don't lag behind. Don't lag behind. You are lagging behind. You are not uploading the notes properly. So these are the iconic mega sale weekends. We have 15% plus 25%. Go ahead and join. You are going to get this. This is the entire course. This is not just one course. This is the entire course of Unacademy. So you can download it here also. Okay, you can just join here. And this also will give you the access to the course. 2 p.m. Botany, Swati Batra ma'am. 3 p.m. Sachin sir. 4 p.m. again, it's my session. So join with me. Okay, take care. Join our Telegram channel, YouTube, classes, PDFs, t.me/Neet Elixir. Join it for all the informations. Here you can get and you can use the apply coupon on the next page, and that is up to 0% off, up to 10% off, up to 5% off. Then the code is AVLIVE. That's the code you are supposed to apply. Whether you join for the special classes, whether you join for the plus courses, whether you join for any store courses or anything, use the code AVLIVE and join with it. Unacademy आपको download कर लीजिए, select your goal and go ahead with the subscriptions. Join with me on this Unacademy @Anoop Vashishtha, unacademy.com/@Anoop Vashishtha. This is my page on Unacademy. Follow me. This would be changed. This is the old one. Okay. Subscribe. Neet Elixir by Unacademy for the best live classes. Thank you. We are gonna meet at 4 p.m. today. Okay. Bye bye. Take care.